Reinforcement learning. Reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of actions. For each good action, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. In reinforcement learning, the agent learns automatically, using feedbacks without any labeled data, unlike supervised learning. Since there is no labeled data, so the agent is bound to learn by its experience only. RL solves a specific type of problem, where decision-making is sequential, and the goal is long-term, such as game playing, robotics, etc. The agent interacts with the environment, and explores it by itself. The primary goal of an agent in reinforcement learning is to improve the performance by getting the maximum positive rewards. The agent learns with the process of hit and trial, and based on the experience, it learns to perform the task in a better way. Hence, we can say that reinforcement learning is a type of machine learning method, where an intelligent agent, computer program, interacts with the environment, and learns to act within that. How a robotic dog learns the movement of his arms is an example of reinforcement learning. It is a core part of artificial intelligence, and all AI agent works on the concept of reinforcement learning. Here we do not need to pre-program the agent, as it learns from its own experience without any human intervention. Example: suppose there is an AI agent, present within a maze environment, and his goal is to find the diamond. The agent interacts with the environment, by performing some actions, and based on those actions, the state of the agent gets changed, and it also receives a reward or penalty as feedback. The agent continues doing these three things: take action, change state, remain in the same state, and get feedback, and by doing these actions, he learns and explores the environment. The agent learns that what actions lead to positive feedback, or rewards, and what actions lead to negative feedback penalty. As a positive reward, the agent gets a positive point, and as a penalty, it gets a negative point. Terms used in reinforcement learning: agent, an entity that can perceive, explore the environment, and act upon it. Environment, a situation in which an agent is present, or surrounded by. In RL, we assume the stochastic environment, which means it is random in nature. Action, actions are the moves taken by an agent, within the environment. State, state is a situation returned by the environment, after each action taken by the agent. Reward, a feedback returned to the agent, from the environment to evaluate the action of the agent. Policy, policy is a strategy applied by the agent, for the next action based on the current state. Value, it is expected long-term retuned with the discount factor, and opposite to the short-term reward. Q value, it is mostly similar to the value, but it takes one additional parameter as a current action, a. Key features of reinforcement learning. In RL, the agent is not instructed about the environment, and what actions need to be taken. It is based on the hit and trial process. The agent takes the next action, and changes states according to the feedback of the previous action. The agent may get a delayed reward. The environment is stochastic, and the agent needs to explore it, to reach to get the maximum positive rewards. Examples of reinforcement learning. Any real-world problem, where an agent must interact with an uncertain environment, to meet a specific goal is a potential application of RL. Here are a few RL success stories. 1. Robotics. Robots with pre-programmed behavior are useful in structured environments, such as the assembly line of an automobile manufacturing plant, where the task is repetitive in nature. In the real world, where the response of the environment to the behavior of the robot is uncertain, pre-programming accurate actions is nearly impossible. In such scenarios, RL provides an efficient way to build general-purpose robots. It has been successfully applied to robotic path planning, where a robot must find a short, smooth, and navigable path between two locations, void of collisions and compatible with the dynamics of the robot. 2. AlphaGo. One of the most complex strategic games is a 3,000-year-old, Chinese board game called Go. Its complexity stems from the fact that there are 10 to the power of 270 possible board combinations, several orders of magnitude more than the game of chess. In 2016, an RL-based Go agent called AlphaGo defeated the greatest human Go player. Much like a human player, it learned by experience, playing thousands of games with professional players. The latest RL-based Go agent has the capability to learn by playing against itself, an advantage that the human player doesn't have. 3. Autonomous driving. An autonomous driving system must perform multiple perception and planning tasks in an uncertain environment. Some specific tasks where RL finds application include vehicle path planning and motion prediction. Vehicle path planning requires several low and high-level policies to make decisions over varying temporal and spatial scales. Motion prediction is the task of predicting the movement of pedestrians and other vehicles, to understand how the situation might develop based on the current state of the environment.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.